Hello everyone, this is Miss Kaylin with Geometry for Veritas. So this is for the missing class that we're not going to be there for February 19th because of the snow day. So we are going to go over homework and go over what we would have been going over in class. So first we will start with going over homework. Your homework was 189, 190, and 192. And then I will just, of course, go over evens like usual. This video will be much shorter than a regular class because, of course, you're not here asking questions and going over different things. So I'm just going to breeze through it, and if you need to pause or if you need to rewatch something, of course, do so. And if you have any questions, please email me, and I will be happy to respond. So 189, the correct answers we have: which choice below is the inverse of the following statement? If lines cut by transversals are parallel, then corresponding angles are congruent. So the answer is B. If lines cut by transversal are not parallel, then corresponding angles are not congruent. So remember, the inverse is just the if not of the original conditional statement. And then number 4, which choice below is the inverse of the following statement? 6x equals 24, then x equals 4. The inverse is going to be C. If 6x does not equal 24, then x does not equal 4. And then number 6, if a figure is a square, then it is also a rectangle. The answer is A. If a figure is a rectangle, then it is also a square. And we're looking at the converse of that one. So, and then page 190 over here. Number 2, if it is, so we're assuming each statement is true, then select a statement that must also be true. Remember that the contrapositive is always true if the statement is true. So here's where it says your hard work will pay off. So number 2, if it is Tuesday, then Sally will have ice cream. So the answer is B. If Sally isn't having ice cream, then it is not Tuesday. So that's just something that is also true. Assuming that what they're giving us is true. Number 4, if two angles are alternate interior, then they are equal. And the answer is A. If two angles are not equal, then they are not alternate interior. Of course, we know alternate interior angles are equal. So if they're not equal, then they can't be alternate interior. Number 6, if a person lives in Texas, then they live in the United States. And the answer is D. If a person doesn't live in the United States, then they don't live in Texas. Both things are also true. So on page 192, I will be going through these answers as well. We did 2 together. We just did an example, a counter example of those angles. Number 4, if C is between A and B on a line, then AC plus CB equals AB. The converse of that is the opposite, and that is biconditional. So we say that IFF, C is between A and B on a line, then AC plus CB equals AB. So that one is true. Number 6, if two angles are supplementary, then they add to 180. That's the converse of the statement. That is true. That is a biconditional statement. Number 8, if a figure is a triangle, then side 1 plus side 2 is greater than side 3. And then the converse, switching it, that is also a biconditional statement because that is the theorem of how we find the side lengths. Number 10, if an animal is a cow, then it is a mammal. The opposite of that, the converse, if an animal is a mammal, then it is a cow. Not necessarily always. A goat is a counter example of a mammal that is an animal that is not a cow. And last one, number 12, if two angles are vertical, then they are equal. The converse of that, if two angles are equal, then they are vertical. Not necessarily true all the time. Two 30-degree angles are not vertical. So if we have just 2 separate angles, they could still be equal, but that doesn't mean that they're vertical. Vertical is when we have intersecting lines. So that is homework. If you have any questions, again, feel free to reach out. So now we are getting to proofs, which are basically all of the things that we have learned, all of the theorems, everything about triangles that we have learned, and we are putting it into a proof. So this is a proof. This is the definition of a proof. This is what I've been talking about this whole year. So a proof is merely a logical argument that demonstrates that some statement is in fact true. This is where the theorems come in. This is where the math comes in. This is where the logic comes in. This is where everything comes in. So here's a real life example. John Doe is on trial for stealing Snicker bars from a convenience store. He is unfortunately caught in the act on tape. The prosecution presents the tape and shows the jury John Doe's face. This logical argument proves that the statement John Doe robbed the store is true. So there's a real example. We have fact proof that John Doe did in fact rob the store. Okay, but if we wanted to prove something like the Pythagorean theorem, considering the lack of camera technology, we would have to come up with something else because we can't necessarily prove that because we have a video of the Pythagorean theorem. So we could A, plug in every single possible value for all sides of every single right triangle that could possibly exist and see if it's true. However, that would literally be impossible because of the infinite number of possibilities. So even so there's option B, using the facts and properties of numbers and of logic to construct an argument that shows that this must be true. So obviously we cannot use option A because that would go on forever and never and ever with just the Pythagorean theorem. So we have to use facts and properties of numbers and different logic to prove that the Pythagorean theorem is in fact true and does in fact work. So this is this is how we do it. So we look at a 2-column proof. So we are given that segment AB is congruent to DC and AC is congruent to DB. So this is the stuff that we use here. This is the pictures given us. This is what we are given to use for the proof. And here is what we are trying to prove. So we are given two things and we're trying to prove that triangle ABC is congruent to DBC. So this is where we have our little T chart. We have statements and reasons. Statements are on the left side, reasons are on the right side. Excuse my cats again, sorry. So we are, AB is congruent to DC, that is given. We do have to split it up and we do have to number it and keep it organized. AC is congruent to DB, that is also given. So that is the things that we are given, but we cannot yet prove that these triangles are congruent because we only have 2 side lengths. So we have to, therefore, continue on. So we have BC is congruent to BC. This is used the reflexive property because it is reflected on each other. And then, so then we can say that triangle ABC is congruent to DBC because of side, side, side. So these are the statements in the proof. We read them from top to bottom. These are the justifications of these statements. So notice that line 4 could not be mentioned earlier because the 3 sides had to be listed first. So any other previous statement, so it does go in order. So it says you can't say John Doe is guilty before presenting the facts. So the order does matter. That is, don't look at that. All right, so continuing on, I'll move this in here so you can see it better. All right, so on that last example, you saw the string things like given, reflexive property, side, side, side. Hopefully you remember some of those things. But given, it appears on the right side of the proof when you are marked the stating information because those are things that can be marked on diagrams. And it also might just be straight up given to you. But those are important to obviously know. And then the reflexive property, all this means is that something is equal to itself. So BC is exactly as long as BC, or X equals X, 3 equals 3, measurement of angle A is equal to measurement of angle A. So this is a property that we would use a lot. It's kind of like shared line, except this is the actual property that you can use for pretty much everything. So here's a couple different things that we can also use. This is what we're given. We're trying to prove that measurement of angle 1 plus measurement of angle 2 equals measurement of angle 3. So this is the statements we have. Measurement of angle 1, measurement of angle 2 plus measurement of angle 4 equals 180. And we know that because of the triangle sum theorem. That is the reason. We have measurement angle 3 plus measurement angle 4 also equal 180 because that is a linear pair. We have measurement of angle 1 plus measurement of angle 2 plus measurement of angle 4 equals measurement of angle 3 plus 4. That is substitution. So don't look at what's marked out. That is called substitution. This is just an example, and we're going to look at that. And then also measurement of angle 1 plus measurement of angle 2 is measurement of angle 3. That's the remote exterior angle theorem. We know that one. So substitution, hopefully it says rings a bell from algebra. So it means two things are equal to the same thing, then they are equal. So if John and Jane are both as tall as Tom, then they are the same height. Or if x equals y and y equals 3, then x also equals 3. So this is just substitution. Basically, you can sub it in and it is equal. Just like number 3 here, the inside of a triangle is 180 degrees. The line, the linear pair, is also equal to 180 degrees. So they are therefore going to be equal to each other. So we also have the addition property of equality of the multiplicative division, subtraction, etc. properties of equality. So this is the basis of most of your algebra. Subtracting from 3 side solves the equation. It also ensures the equality is still true. The additive and subtractive are most commonly used in geometric proofs. So this was just an example. We use the remote exterior angle theorem here. So it looks like it's really easy, and it is. You just have to think about it logically. You have to slow down, and you have to really think about what is in front of you and what you're trying to prove and how we get there. So this is why we did the backwards steps, the backwards theorem. This is why we've learned all of the theorems and everything. And I've made you write down all of those theorems, and we've had quizzes on those theorems so that you know all of your options, because if you know all of the reasons and you can pick and choose from those, it makes it a lot easier. So let's look at, so before we actually start doing proofs, we're going to be looking at the backwards forward method of doing proofs. This is just, it kind of just explains it, makes it easier looking at it. So if you read a section of solving more difficult problems called the backwards method, this is a piece of cake. This is the backwards method we used. Basically, you put out all your questions and then you answered them. This is kind of the same thing. So start with the prove and then work your way backwards. So, and then we need to figure out what we need. So this is a very long explanation here. All of these are going to be very long explanations of exactly what we're doing. Okay, this is not an actual proof. This is the forwards backwards method of doing proofs. And we need to know this so that it makes more sense when we do a proof. So we're trying to figure out what we actually need. So let's see. Let's keep on. So this is an example. Oh, wait. Okay, let's read it. So you start with the proof. In this case, we're trying to prove that triangle ABC is congruent to triangle DBC. Okay, that's what we're trying to prove. This seems backwards because we part ways with the word proofs and it towards the bottom. So we put backwards method 1 here. So when you read prove, you see that you were asked to prove or show that 2 triangles are congruent. Now you probably ask yourself, how am I supposed to do that? This is where we're going. That's actually the great first key question. How can I prove 2 triangles are congruent? The answer is, of course, we have side, 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 angle, 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 side, hypotenuse, leg. We have all of these options. We basically have to fix it or pick from those. So we have backwards step 1 is ABC is congruent to DEF by some property. We don't know what it is. Well, here you are, because which one should you use? Now we start with the given information. We have first step 1, we have AB is equal to DE, we have AC is equal to DF, and we have BC is equal to EF. Those are all given to us because of those congruence lines there. Those are given and up here. So now we can say, because we have 3 pairs of congruent sides, this is side, 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 and now you're back at backward step 1, which gives you the answer. Now your proof is complete. So basically, you start with the final question, what we need to get at the very end, and then we go back to the top and see what is given to us and kind of fill in the blanks and see what we need. All right, so now we are actually looking at proofs involving congruent triangles. These are the ones we're probably going to be doing a lot. We're going to be doing different types of proofs, but this is the one, not the most important one, but the one that we really hone in a lot. So all you have to do is explain basically what's in the proofs. So this is the analysis okay? This is, you don't have to do this every time. This is the proof, but the analysis shows you exactly why and where this came from. Okay, so we are given that AB is congruent to DE, AC is congruent to DF, and angle A is congruent to angle D. Those are the things that are given to us. We're trying to prove that these two triangles are congruent. Okay, so working backwards, we must ask our key question. How can we show the two triangles are congruent? The answer, the triangle congruence theorems. Side, 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 all of the triangle congruence theorems. Okay, so we need to get there somehow. Somehow we need to get to the triangle congruence theorems. Good thing we know all of them, and good thing we practice them a lot, because it'll be easy to choose from. So this gives us backwards step 1, 2, and 3, because those are all given. We're given two sides and an angle, okay? So we're given an angle D and angle A, which is sandwiched in between the pair of congruent sides. So that means we have the triangles are congruent by side angle side. And your proof's complete. That's all that says. That's how we do a proof. Okay, so again, we have two triangles here. We're trying to prove that these two triangles are congruent. Okay, working backwards, we ask our key question. How can we show the two triangles are congruent? The answer, triangle congruence theorem. Okay, we don't know what triangle congruence theorem. We have all of the options. Now we need to figure out which one it is. So we are given that AB is congruent to CD and AD is congruent to CB. Those are what is given to us. So these sides and these sides. But that's not enough. We need another pair of sides or an angle between them. So looking at the diagram, we have BD is congruent to BD as a shared line. So then we can use that because that is a shared line, and we can use the reflexive property. So when it's a shared line, we use a reflexive property because it is the same. Looking at angles, we couldn't find an angle because we don't have parallel lines here, so we can't say that the alternate interior lines or alternate interior angles are equal because they're not parallel. So really, another side is our only option. But good thing we can't do that. So now we can say these two triangles are congruent because of side, side, side. All right, last one on this page. We're trying to prove, again, these two triangles are congruent. So we have AE bisects BD. So that means these sides are going to be the same and these are going to be congruent. And we are also given that angle B and angle D are congruent. So working backwards, we must ask our key question. How can we show the two triangles are congruent? By using a triangle congruence theorem. Okay, so now we start working forward, listing all the given information. We have angle B is congruent to angle D. That's given. We have AC bisects BD, which is given. Okay, that's what's given to us. We can't assume anything yet. I mean, it's not assuming, but now that's what's given, and now we have to use what is given to us and then prove the facts. So now we can say that BC is congruent to DC because of the definition of bisect. The definition of bisect is it is split into two equal parts. It is bisected. So we can say that those sides are congruent. Now we can also say that angle ACB and angle DCE are congruent because those are vertical angles. So now we have the two triangles are congruent because of angle, side, angle. So we have the vertical angles, angle B and D, and then we also have these two lines that are bisected. So we could have listed these AC and CE, but that's not what we needed because that's why the backwards method is important, because we need to look at what we need in order, instead of just listing everything that is given to us. All right, I know this is a lot of information, but we're gonna keep going. So I'm pretty sure yours is blank here, but I put it here so that you can have it. This is my version so that I don't have to, you can read it. All right, anyways. So number one, we are given that BC is congruent to EF. Let me get a marker. All right, let me write on this for you. So we are given that BC is congruent to EF. BC and EF. We're getting that angle B is congruent to angle E. And we are given that angle C is congruent to angle F. Okay, so working backwards, we must ask the key question. How can you show these two triangles are congruent? By using a triangle congruence theorem. We don't know which one, so we're going to see what is given to us. This is our statements. This is our reasons. We have our T-chart, statements, reasons. Number 1, BC is congruent to EF, given. Angle B is congruent to angle E, given. Angle C is congruent to angle F, given. Amazing. Now we have enough information to actually prove it. Triangle ABC is congruent to triangle DEF because of angle side angle. That is the theorem. That's it. Thankfully, it was all given to us so that it is easy enough for you to follow. All right, number 2. Given, we are only given that AB is congruent to BD. So AB is congruent to BD. That is what's given to us. Now we have to fill it in a little bit. All right, so working backwards, we must ask our question. How can the two triangles are congruent? The answer, the triangle congruence theorem. Anyways, so start working forward. We're listing our given information, which gives us AB is congruent to BD. That is given. And we can also say that BC is equal to BC because of the reflexive property. That is a shared line. We can use the reflexive property. So now we have two sides. Now we have a hypotenuse and a leg. Thankfully, those are right triangles. So we don't need to do anything else. We can say that these two triangles are congruent because of HL, because of hypotenuse leg. All right, number 3, we have that AB is parallel. So AB is parallel to ED. Okay, whenever you have parallel lines, you're looking at different types of angles with a transversal. And we are also given that AC is congruent to EC, which is written for us here. All right, so working backwards, we must ask our question. How can we solve that two triangles are congruent? By using the triangle congruence theorem. So, which gives us step 5 here. So we're going to start working forward with what is given to us. AB is parallel to ED, given. AC is congruent to EC, given. Okay, that's all that's given to us, but we don't have enough. So now we're looking at, we could do the vertical angles, or we could do the alternate interior angles. So we can say angle A, angle A is congruent to angle E because of the alternate interior angles. Those are parallel lines, so we can say that. And then also angle ACB and ECD, DCE, those are equal because they are vertical angles. Now we have an angle side angle. So we can say the two triangles are congruent because of angle side angle. Hopefully it's making sense to you. I know I'm talking a lot. Hopefully everything that we have learned, you're like, oh, finally we're putting it together and you're actually understanding. But let's continue on. Let's do some more examples. So number 1 here, we're given that AB is congruent to DE. It's already marked for us. We're given that angle B and angle E are congruent, and angle A and angle D are congruent. So we're trying to prove that ABC is congruent to DBC. We're trying to make sure you always look at what you're proving, because sometimes we're not proving triangle congruence. In this case, of course, we are. So our statements, we have AB is congruent to DE, given. Angle B is congruent to angle E, given. I think that these are fill in the blank for you. The ones that are more italicized are what should be in your notebook. And then angle A and angle D, that is also given. All 3 of those are given. We don't need any more information. We can say that they are congruent because of angle side angle. Number 2, we're given that PQ is congruent to RS, and we're given that angle PQS and RSQ are congruent, which are already marked for us. If this does not have it up here, then you can still say that those are given to you. But it just already writes it out for you. And again, we're proving that these two triangles are congruent. So we are given PQRS We're given angle PQS and RSQ, given QS and QS. You're not going to write shared line here, okay? Because although it is a shared, you would have to like write the definition of a shared line, things like that. Reflexive property, that is a property, kind of like a theorem, is always the same. You use reflexive property when you have a shared line, okay? So now we have side, angle, side. So now we can say the two triangles are congruent because of side, angle, side. All right, number 3. We're given AB is congruent to DE, AC is congruent to DF, and BC is congruent to EF. We're trying to prove that the two triangles are congruent. So you write out your statements given. All 3 are given. All 3 are written out for you. So we can say the two triangles are congruent because of side, side, side. They will get a little bit more difficult, but this is just the beginning. So it is repetitive, but it's a good thing. That means you know and you remember what you're doing. All right, number 4, we are given that angle L and angle N are congruent, and angle LOM and NMO are congruent. So we have 2 angles here. We're trying to prove that the two triangles are congruent. So angle L and angle N are given, angle LOM and MNO are given, and then we can say that MO and MO are congruent because of the reflexive property, and then both triangles are congruent because of angle, angle, side. Making sure that you are using the correct triangle congruence theorems, because if you do ASS or SSA, those are not theorems. Those will not work. And there will be times where you cannot prove it. Okay, so just saying. All right, number 5. We're given that AE bisects BD and that angle A and angle E are congruent. We're trying to prove the two triangles are congruent. So angle A and angle E are congruent. That is given. We're also given that AE bisects BD. Those are 2 things are given. So therefore we can say that DC is congruent to BC. These 2 lines here, because of the definition of bisect. That is a reason. The definition is a reason. Then we can say that angle ACB and angle DCE, ACB and BCE, these 2 angles are congruent because they are vertical angles. Now we have angle, angle, side. We can say the 2 triangles are congruent because of angle, angle, side. And then last one on this page. Actually, let's skip that one because I don't know if you can read that really well. And we're just going to do some more examples over here. So let's go to number 7 on page 199. All right. There are lots of these examples. So some of this will be, look at that. We'll look at that in just a second. All right, so let's move on to doing some more. $199. Let's do one on here. Let's do number 10 because that looks scary. All right, so we are given that N is the midpoint of MO. Okay, we're also given that LM is congruent to OP and LN is congruent to NP. So writing out our givens, always do that. Always do our T-chart. Left side, LM is equal to OP, given. LN is equal congruent to PN, also given. We're also given that N is the midpoint of MO, which is given. Okay, and because we can use that, because we know what midpoint is, we can say that MN is congruent to ON because the midpoint, the definition of midpoint. Right, midpoint, that's in the middle, those 2 sides are congruent. So now we can say the 2 triangles are congruent by side, side, side. Okay. Let's do number 12 here. So we are given that QT bisects SP. We are also given that SP bisects QT. So QT and SP basically bisect each other. Those are 2 separate things, and we are given. We have to know what bisect means in order to solve this. Okay, so we can say that QR is congruent to TR, the definition of bisect. We can say that PR is congruent to SR because of the definition of bisect. Now, we can't say that these are congruent because we don't know anything about those. We don't know these angles, these lines are not parallel, so we can't say anything about those angles. But we can say something about these. Angle QRP and SRT are congruent because these are vertical angles. Now we have enough to prove that these triangles are congruent. We have side, angle, side, and so therefore we can say they are congruent because of side, angle, side. All right, let's do some more. Try to do some where they're not all given to you so that you can fill in the blanks a little bit better. All right, let's do number 16 here. We're given that LP bisects MO, and we're given that LO is parallel to MP. So always writing out what is first. And seeing what we are proving. We're proving that these two are congruent. So LP bisects MO, which is given to us. So, and then LO is given also. So we can say that LN is congruent. LN is congruent to PN. That is not given to us. Don't write given. It's the definition of bisect. We corrected that. So the reason for number 3 is the definition of bisect. We still only have one side. Okay? We got to go some more. But we do have parallel lines. And whenever we have parallel lines, you're looking at corresponding. You're looking at alternate angles so that we can use those angles. So we can say that LNO and MNP are congruent because those are vertical angles. Oh, I skipped one. It's okay. Same thing. Those are vertical angles. And then we can say also that angle L and angle P are congruent because those are alternate interior angles. So now we have angle, side, angle. We can say that triangle LNO is congruent to M and P because of angle, side, angle. All right. So let me look at the next pages. All right. So your homework. We are not going to do proofs involving CP/CTC yet. That will be next week. You will most likely have a sub next week. I will scan the test. There is a test. It looks like this. Let me go over it. We also have a quiz as well. We will go over that as well. So we are given, this is what you are given. These are the questions. This is actually already done for you. So you have some of it, you just need to fill it in. For those two, you're trying that those are congruent. These two, we're not looking at two congruent triangles, we're looking at angles. But again, we are just using what you learned, like substitution, the angle of bisect, things like that, supplementary angles, just to prove looking at these. Make sure you're looking at what you are proving. And as well with these last two, the transitive property of congruence. If two segments of angles are each congruent to the third line segment of an angle, then they are congruent. So if two segments or angles are congruent to one line segment, then they are congruent. That is something that we can use as well. It's written out for you. Again, you're just looking at the angles of those. So that is the test that you will have. And then also you will have the quiz. So this is the quiz that you were supposed to take today. I will send this out, and then you'll also get a quiz next week. which has a lot of the same things. So this is what you're given. This is the logic. There's nothing about proofs on here. This is just logic. So you will need to complete that. If you cannot print it out, then you can just write 1 through 10 and write your answers on a piece of notebook paper. Please do not cheat. Please do this like a quiz that you would do in class. And then you will have a quiz next week that is on the same things, except instead of it being fill in the blank, you will have to write some of it out. So you need to make sure that you know all of this stuff forwards and backwards, and you would be able to teach someone this if you had to. So, today you did proofs. You did not have a test, so your homework will be, the quiz obviously you would have been taken in class, so you will have to do that. But your homework will be, oh my goodness, don't look at that please. Page 202 and 203. So page 202 and 203, these are, wait, did I just say that you had a test? Hold on. I'm trying to figure out what you need. Okay, you will have a test. I will send that out and I will scan that. But since it's only like 9 questions and it's fill in the blank, you still will have, I'll just give you 1 page of homework. So you will have the quiz, which you need to do. You will have this page of homework, page 203, and then I'm giving you all of the answers, but that's okay. Page 203, and then you will have the test. So I would suggest doing the quiz, or watching this, of course, then doing the quiz, and then doing the homework, and then the test. The test is short, should not take long. Again, if you do not have a printer, if you can't print it out, just write it all out on notebook paper. Make sure you number it so that you can follow along. But I will post this, and next week I most likely will not be with you. Miss Doreen will be with you, and she will do everything as I do, and she will have all the materials, all of my stuff, everything's already printed out for her. So please reach out if you need anything. If you have any questions, feel free to watch this back or watch as many times as you need, or email me if you need help and if you're not understanding anything. But that is it for now, and we will continue proofs next week. And that's it. All right, thank you.